I'd like to thank the great folks over at PCBWay for sponsoring this video. Got a brilliant idea and want to bring it to life? Introducing PCBWay's cutting-edge 3D printing service. Just upload your CAD files, choose your measurement types, choose the type of material, which ranges from regular known plastics to resin to several types of metals. Need it fast? Experience rapid turnaround time with PCBWay's efficient 3D printing service. All right, guys, so I'm going to get back to the cone motor hopefully this weekend. I've changed all the magnets so they're all in repulsion mode. But until then, I'm going to play around with my other Newman motor, not this big guy here, but the other one that is this guy here. That's a half Newman, I guess you'd call it. And so it's actually more like a Windows motor. This was the first one that I wound, and I didn't wind it very good. I used really thick wire, so I put it off to the side. I since 3D printed this holder for the bearings, and then a little, let me stop that, a little support piece for this to sit in, and it's screwed in. And I've been running various rotors. I 3D printed out that red one that I just showed you, but I'm going to test a few other ones, so stay tuned. And I'm also going to try a couple of different circuits. I'm going to try the normal JL94 circuits that I've been using, but I'm also going to try one from K Energy. I bought one of his optical circuits, and I 3D printed out the interference, or the tab that goes through the optical sensor. What I need to do, though, is print out a stand for the optical sensor itself, one that I can adjust it up and down, which has been kind of a pain for me. I don't know why I find that so hard to do. But let me get that guy out and take a look at what I need to design. So stay tuned. All right, so this is the opto circuit, and I'm printing out an extension piece to bring this up a little bit higher. This does slide up and down. Here's the latest rotor. These are 1-inch square N52 Neomags. And this is a piece that once the Neomag goes in there, this gets press fit in there. And it's a really tight fit. I don't think I'm going to need to screw them in, but I probably will anyway. Right now, the other 4 Neomags are in my PCBWay nylon SLS rotor, which I'm also going to bring over here and pop inside this guy, because I really want to play around with the opto circuit as well as some of the other circuits I have. And I may even try to do it the traditional Newman way with a commutator. I'm not a big fan of that. I know it puts out a lot of energy, but anyway, stay tuned. All right, so here's the first test with that particular rotor, putting out a lot of power. I'm going to daisy chain a few of these. It's not going very fast, but that's all right. I only have it running on 12 volts, and this is large wire, and it's only half a coil. So let me see if I can daisy chain a few more of these guys, see how much more power I can get out of it. Nice and quiet, though. Stay tuned. There, I got this guy daisy chained. There's 1, 2, there's 5 of them on there. I don't know what these are rated for. Got these little guys right here. Here's the back of them. They have a bunch of small capacitors on there. I don't know what these are rated for. but it's putting out a lot of light, a lot of power. I'm gonna see how many more I can daisy chain on there. It's not pulsing for me in real life, but on the camera it's got a little bit of a pulse. Pretty cool. Stay tuned. So here's the, excuse me, here's the nylon rotor that PCB Wave made for me. Those guys right there. This is done with SLS printing. I didn't know you can do that with nylon. I thought SLS was only for a type of metal, you know, powdered aluminum, titanium, stainless steel. But apparently you can do it with, excuse me again, you can do it with nylon and a lot of other materials, which I didn't know. These are the other 4 1-inch cube mags that are eventually going to go in there. I really don't want to take this apart. I actually added this piece in here to hold the magnets in place. This thing is heavy. All right, I want to get this guy in there and try it out. So stay tuned. So it's going okay. I think because of the size, I need the bigger size in there to make more, to get closer contact with the outer wall of the coil. I mean, it's still working really good, putting out good output. But yeah, these rotors were meant to have coils on either side of them, not be down inside of it. But it's working out pretty good. Really bright output. I really should add more. Although the safety neons aren't even lit, so I guess I'm all right. I love that rotor. Took me a while to design it, but PCB Wave did an excellent job printing it. The tolerances were right on. All right, stay tuned. So I'm trying these different bulbs that I have. This is a really bright one. Holy crap. Let me get it off to the side so you can kind of see it. It's one of these. But I think I can daisy chain even one of those. All right, stay tuned. Yeah, so I built this, excuse me, this daisy chain one a while back. Didn't think it was going to work. But it's working well. I even have space for another one. So it's about 36 volts going into this guy. All right, let me see if my base is printed out for the opto circuit. Stay tuned. All right, so I got everything printed out. I wanted to show you guys a couple of things before I keep going. A couple of tools that I could not do without. I mean, I probably could, but they make life a lot easier. One of them is the magnetic film. It not only, it shows me the separation between the north and the south poles, but it shows me the line. So here it shows this is a pole and this is a pole. And without that, especially with the square neomags, I wouldn't know where exactly to put the cube magnet. And then another thing I wanted to show you. So I was a big fan of these guys here. And it would normally beep. So that's the North Pole, North, South Pole. These things are a pain in the ass, so I upgraded to this. It doesn't cost much more, but it's so much better because it takes normal batteries. These things take those little, I don't know what you call them, those little ear battery cells or whatever. This one is a much better system. I got it on Amazon. Magnetic polarity tester. It's just a more solid for about the same price. And again, other than my 3D printer, wire magnets, and bearings, I use these all the time. Anyway, let me get this guy set up. I need to take the magnets out of here and put them in this bigger rotor. Hopefully it'll fit. I measured it. I hope it'll fit. But yeah, I think with the larger rotor, I'll get better results. Anyway, stay tuned. So I remember when I put this guy together that it was in 2 parts. And I also remember that I needed to put blocks of wood in there, otherwise the magnets would crush my fingers. So this guy goes in there like that. So getting them in there was easy. I'm not sure how the hell to get them out. This is connected to this. This is all one solid piece. And I damn sure don't want to destroy this. I really don't even want to take these magnets out. It was really hard getting them in there. Damn. Something caught in my throat. Can't seem to get it out. I don't want to wait on new ones to come in. Oh, boy. Yeah, I'm not really sure what I could do. Because once I take this bottom piece out, they're going to want to slam in. Although I do have this piece right here. Or this. All right, let me think about it a little bit. I'll probably just put a couple of screws in there, slide this out slowly. As I get it up high, I can slip something underneath there. Yeah, okay, stay tuned. Well, it did exactly what I didn't want it to do. I put a couple of screws in, I lifted it up. I didn't realize how thin this piece was. And they slammed together. Thank God there was this piece right here. Now I just got to figure out how to get these out. But I'm not going to do that on camera. Ay, ay, ay. Yeah, see, I have them in the correct way because you're not going to see any line. All right, I think I can just use another magnet to help lift it out. Put a dowel in here. All right, stay tuned. All right, so I got it together. This is one heavy unit, and I realized that I kind of made not a mistake, it was a choice, but I should have gone what I normally do. I normally do a 22.2 millimeter recess on both sides for the bearings. But I have bearings in the housing itself, but I usually opt for at least 4 bearings, 2 in the rotor and 2 in the housing. I don't know why I went the other way this time. Which means, even though it's a tight fit, it's not tight enough. So I'm going to have to either find or 3D print out, I forget what I call them. I think RD3DP calls them brakes. I don't call them brakes. It's kind of like this. It screws to the rotor housing itself, and then I usually have a little 4mm hole to take a set screw that I can tighten down up against the rotor rod, this guy here. So let me see if I can find one of those, or a couple of those. I really only need one, but for balance, I always like to have two. I know I have some around here. I'm just debating on whether I should reprint this, which I'm not going to do. When I was pressing in the magnets, these are all pressed fit, I heard something crack. I think it was just the vise itself, because the print itself, the rotor itself, seems to be fine. And I'm also debating on whether I should put at least 2 screws in each of these. There's no way the magnet's going to come flying out. There's just no way. Too much material in its way, and they're a press fit. These are also a press fit, but if I got this at high speed, these could come flying out and act like little eyeball projectiles, which I really don't want to deal with. But I didn't countersink these, that's not a big deal either. And I don't want to put 4 in. I think 2 in each. It's just a matter of placement. Let me think about it while I find the other part. I should have did it like this guy here. You know what? I have a bunch of these. I wonder if these will even fit. I know they will, because they were made for the same setup. Let me think about this. I could reprint these guys. That's not a big deal. And have the holes already in there. All right, stay tuned. All right, so this is the thing I was talking about. And it goes right here, and it'll get screwed in. And then, of course, I'll have a set screw in there. I wanted to show you guys this. I've been experimenting with different ways of printing stuff. So under normal circumstances, printing something like this is not hard. But sometimes the smaller holes can be a pain. So I tried printing it where it's still flat on the bed, but the holes, there's an indent where the hole would normally go. And then I just pop that out with a drill. Seems to work. But yeah, so now I got to tap this, put a set screw. I don't really need to even tap it. The set screw itself will kind of tap it. And then I could lock it to the shaft. I have to drill this guy out first, though. Yeah, I was having a problem for a little while, not long, like for a day, where every time I printed out something that had small holes, it would leave a booger on there and it would catch it, and then the print wouldn't fail, but it was just a pain. And I thought, I don't really need to print the hole all the way through. And printing on a flat surface like this is almost effortless. It is effortless for the 3D printer. God, I love 3D printing. So many things. I got to scrape. This is old glue. I took this off of an old stand. Have my plastic scraper. I use this because if I don't, I will cut my fingers every single time. All right, stay tuned. All right, so I got the big guy hooked up, and I have it hooked up to one side of my dual JL94 circuit. Decent output. I could change that to the 3-1, and because it's not going very fast, I'm not going to worry about screwing those things in. Let me turn it up a little bit. Really bright now. So it looks slow on the video, but it really isn't. It's not going super fast, but it's going at a decent clip. All right, let me bring you back for the opto circuit. Stay tuned. Very cool. I have the opto circuit hooked up. I don't have it timed properly, but it's definitely working. And I don't have anything going to the output. I need to do something like that. But AK, I'm using your opto circuit, man. It's working great. I love that thing. It's so simple. And I finally figured out a way. I put ball bearings in this base here to weigh it down. All right, let me get some output going and figure out a better one for that one there. All right, so I have a new disc on there. This one has, you can see it through the video, it has 6 tabs because there are 6 magnets in there. So that seems to work pretty good. The output is pretty solid for me, but it's blinking for you guys. Pretty cool. I love this opto disc. I'm trying some different ones. I have a 3 and I'm printing out a 2. There, stay tuned, hold tight. Yeah, that's still the 6. I found that if I put the rotor offset a little bit to one side, I get better performance, probably because it's only half of a coil. It's set up kind of like a Windows motor. This is really big or large gauge wire. Let me change it out for the 3 and see what that does. Stay tuned. The 3's not working as well. I don't even know if it's covering it up at all. Now I think the 6 works the best. Let me change it out to a 2. Yeah, that's back to the 6. Yeah, the 6 definitely works better. So if the 6 works, I was thinking the 3 must be able to work too, but I guess not. Let me try setting it up so that it's blocking, because I didn't match the cutouts or the blocking part with the magnets. Let me try that. Stay tuned. So I have it set up so that every time it blocks, it's in line with one of the cube magnets. Again, it's spinning a lot faster in person than it is on the video. You know what I forgot to do too? I did not tie the rotor down to the, see, look at, I didn't tie it down to the, yeah, I got to do that. Stay tuned. Yeah, I got it tied down now, and I also have the shaft locked in place. Seems to be working a little bit better. I think the other one is ready. Let me go get it. So I'm still on the printer. Stay tuned. So I'm still using the 6. I forgot. This is a really cool circuit from K Energy. I have a switch here that I can switch off the output, which is really nice. Good for charging up batteries, I guess, or if I just want to change the output to something else. All right, let me go get that other piece. All right, this one has 4 prongs. So the best so far has been the 6 prong, but you know what? I'm not getting the action I want to get, so I'm going to break out my other Newman motor and use it with the opto disc. So stay tuned. All right, so I'm got my regular Newman motor. Let me put my lid on there, my safety lid, because those magnets have come flying out of there before. I've got the, oops, pulled that out. Hold on, stay tuned about that. All right, So I've tried all kinds of discs. I tried 2, I tried 6, and the one that works the best with a dual rotor with just, 2 poles is the 1. And it's working really good. I love this circuit, but I couldn't get it to work, so I'm printing out a 2-prong one. And I think that one should work. But I know it's all about placement, where to place this guy. Yeah, the first time I didn't have one of these lids on, I had a dual rotor in there, and I had barrel magnets on the end, and I didn't secure them. They came flying out. If you look at some of my past videos, you'll see it. But yeah, the single blade, and I'm so glad I fixed this, because this was a real sticking point for me, getting it to where I could just put it somewhere and it would be okay. And again, this is much brighter and more steady for me. But yeah, let's turn it up. I don't have it very steady. Let's turn it back down. I have it on some pieces of wood because I had to bring it up higher. I'm going to print out a ring that'll go underneath there. So let me hook up some of my other lights to it, see if we can get the output to increase. But I'm really curious to see if the dual blade is going to work as good as the single blade. Let me adjust it a little bit too. I bet you I can get it going better if I have it adjusted better. Stay tuned. Wish I had that rolling. It actually self-started. I adjusted the blade a little bit, so if the poles are running this way, the blade is running this way. And if I remember correctly from K Energy, it actually activates when the blade goes and it interrupts the opto signal. I always thought it was the opposite way. Yeah, the single blade's working really good. Now I'm thinking maybe the double blade won't work, because it's working because it's pulsing one of the poles. Let me put my lid back on there. All right, let me get the other one off the printer. Actually, no, let me hook up some more lights. Stay tuned. Here we go. I got the 3 bigger lights hooked up. So that's about 36 volts coming out through here. I really got to print out that ring for the bottom of this. I don't like that shaking. But it's working really good. Oops. Let me slide this back over. Oops. There we go. Oh, I think I disrupted the timing. All right, let me go to the printer and see if the other one's done. And then we'll be done with this. Get back to the comb motor. Stay tuned. Yeah, so the one tab on these guys is the way to go. I made this one a little bit too long, so I have to set it off a little bit. There it goes. But yeah, I'm getting really good output. Let's crank it up. No, let's not. Yeah, I think one of these guys is not connected all the way. Anyway, that's enough with messing around with this. I got to get back to the cone motor, which I made some major changes on, oh, here it is. Got to put my PCB way thing up there. Anyway, yeah, I wanted to play around with the with the Newman motor, and it started with that other half one, which was all right, but not as good as this guy here. Actually, there's one more thing I want to do before I go away from here. The best way to run this guy at super high speed is with my dual JL94 circuit, so stay tuned. Yeah, that's the best way to run it. This thing is flying now. Whoa. You put that top back on there. Really solid output. Let me turn it down a little bit. Yeah, that's the best way to run this. For me anyway, for my applications, or for my pleasure, if you will. It's kind of crazy. All right, back to the cone motor. Ciao. All right, so I had to show you one more. So, running the optical disc correctly, I spoke with K Energy, the guy who makes these great circuits and has got a good YouTube channel, told me, and now it's running really well, that for this type of setup, unlike the other one, this one needs to be a 60-40 split on the optical disc, kind of like this. And if you can see, it works really well. In fact, I'm going to try to put this guy back in there to see if I can get it to work. Except for that guy, I think I still need the 6. I need this guy. Let's turn it up a little bit. I gotta put like a rubber seal on this guy so it doesn't make that weird noise. Yeah, it's working really good now. All right, oops. The vibration is causing this guy to move. All right, ciao.